Cambridge International AS and A-Level Mathematics, Code 9709, 2020 Specimen Paper 1, Pure Mathematics 1. The link to the question paper is in the description below. Hi, I am Babak Majidzadeh Garjani. In this video, I am going to solve the fourth question of this sample paper. Okay, let me read the question for you first. A curve has equation y equals to f of x. It's given that f prime of x is equal to 1 over square root of x plus 6 over x squared, and that f of 3 is equal to 1. Find f of x. Okay, so you see that the derivative of a function is given. You are supposed to find the function f of x. You immediately realize that the trick would be integration, of course. And you know that when you integrate a function, you have 1 degree of freedom, and that is the constant of integration left at the end. So this is why that you can immediately see that this extra piece of information is provided so that you will be able to fine-tune and find that value, the constant of integration c. Okay? But before tackling the problem immediately, I want to make sure that you know how to calculate the integrals of this type. So you have an integral of ax plus b to some power n dx, and when n is not equal to minus 1. Okay, so I want to make sure that you can solve these integrals. Of course, if I ask you the same question, instead of writing ax plus b in the base, if I write x, just x in dx, and I mention that n is not equal to minus 1, then of course the answer is given in the formula paper, and that is this one, yes? Okay, you might have some guess that more or less the same formula or very similar formula will work here. Okay, yes, you are right, but you need to be careful of a prefactor of 1 over a in this case. So what I want to show is that integral of ax plus b to the n dx will follow exactly the same rule here, okay, with one exception, and that exception is very important. So I would write this. I would write the answer to this integral to be ax plus b to the power of n plus 1 divided by n plus 1, but then I have to multiply by an extra factor of 1 over a, okay, and then of course a constant of integration. Okay, so let us prove this formula first, that why this formula is working. Of course, one way to prove this is to take the derivative of the right-hand side and prove that this becomes this function. Okay, so let us follow this method. I take the derivative of what is on the right-hand side. So what is on the right-hand side is 1 over ax plus b to the power of n plus 1 divided by n plus 1. So if you don't mind, let me take these brackets away, put the product here, okay, and then plus a c. And I take the derivative of this combination. Of course, the derivative of constant c is 0, so I need to concentrate to take the derivative of this b term, okay? But look, here a, 1 over a is a constant, n plus 1 is also a constant. Why? Because the integration variable is x. So whatever except x is assumed to be a constant. If I want to take the derivative of that, so I don't care about these prefactors, okay, constant prefactors. One of them is 1 over a, the other one is 1 over n plus 1. So I put them aside, then I will concentrate to take the derivative of this bit, yes, of this part. But then here, to take the derivative of this part, I have to use the chain rule. Okay, so how? I have 1 over a times a plus n plus 1, and then this n plus 1 here goes back, so it becomes n plus 1 ax plus b to the power of n plus 1 minus 1, which becomes 1. But so be careful. This is not finished. You need, by the chain rule, you need to multiply by the derivative of the of the base as well. So if I continue, this n plus 1 here and that n plus 1 are cancelled. So I will get 1 over a times ax plus b to the power of n multiplied by the derivative of this is just simply a. So multiplied by a. Then again, this a and that 1 over a are cancelled. So this becomes just ax plus b to the power of n. And if you compare this one and the integrand function, you will see that they are the same. So it means that the formula that we got here is completely correct. Okay? Now let us go back to the problem. So in this problem, f prime of x is given to be 1 over square root of x plus 6 plus 6 over x squared. Okay, so if I want to find f of x, I need to integrate this given function, yes? But of course, I can split this integral into two pieces, the integral of the first bit plus the integral of the second bit, yes? Then I can write the integrand in the first integral to be x plus 6 to the power of 1/2. Hopefully you have this experience. And then 6x to the power of, so I can just do them simultaneously. So let me write this one again as it is. And now I move everything in the denominators to the numerators. So this becomes integral of x plus 6 to the power of 1/2 dx plus 6 is a constant. I can pull it out from the integral, and then I have x to the power of minus 2 dx. Okay? For this part, for this integral, I want to use this formula. Okay, so here a is 1 in this case, and b is 6, and n is minus 1/2. So I use the formula and write the answer. So the answer becomes 1 over a, which is 1 over 1 in this case, multiplied by x plus 6 to the power of minus 1/2 plus 1 divided by minus 1/2 plus 1. Then I have plus 6. By the formula in the formula paper, you get the same thing here. It's x to the power of minus 2 plus 1, minus 2 plus 1, and then of course I have a constant of integration. So what I have done is calculated that the primitive function, but now I simplify it, okay? Here, minus 1/2 plus 1 is positive 1/2, but this positive 1/2 is in the denominator, so it becomes 2 in the numerator, yes? And this 1 over 1 is just simply 1, so this you get 2, and then you get x plus 6 to the power of minus 1/2 plus 1, which is positive 1/2, yes? And then you have here minus 2 plus 1 is negative 1. Negative 1 multiplied by 6 becomes negative 6. And then you have x to the power of minus 2 plus 1, which is minus 1 plus c. Okay? Finally, I will write this in a more familiar way. What do I mean by familiar way? So here I would write f of x is equal to, instead of writing this fraction power, I use the square root symbol. So this becomes a square root of x plus 6. And then the next one becomes 6 over x to the power of positive 1. And then I have this c. So finally, this is the general form of the function that I was looking for. But let us go back. Look here. I have an extra piece of information here, f of 3 equal to 1. So I will write it here. F of 3 is equal to 1. So what does it mean? It means that if I go to my function and then replace x with 3, the answer is supposed to be equal to 1. Okay? This will give me the opportunity to be able to find this c. So let us do it together here. How should I do? I replace every x here by 3. So then it becomes 2 square root of 3 plus 9 minus 6 over 3 plus c is equal to 1. Oh, sorry, this was not 9. This is 6. Yes? Okay, and then 3 plus 6 here. 3 plus 6 is 9. The square root of 9 is 3. And then if I multiply it by 2, it becomes 6. Yes? So this implies that I have 6 minus 3. 6 over 3 is 2. So it becomes minus 2 plus c is equal to 1. So this means that 4 plus c is equal to 1. By moving 4 to the right hand side, it becomes minus 4. And then I have c is minus 3. Yes? And if I replace it here, then I will have my function. So answer is f of x equals to 2 square root of x plus 6 minus 6 over x minus 3. So that is my answer. Okay, thank you for watching the video and good luck.